Hey everybody, Mr. Gibson here. So for this assignment, you guys will be doing a Gizmo about electron configuration. So not only will this revisit some of what we learned about orbital notation, but it's going to give you the opportunity to start exploring the idea of electron configuration, which is another way to express an element's electrons following the quantum mechanical model. I honestly think this is a little bit easier than the orbital notation because you're not drawing boxes and arrows and whatnot. With electron configuration, you're just writing the number of electrons. So let's dive in and see what's going on. So you're going to go to the Gizmo website here. You're going to log in. And so like these are your all's classes. I'm going to add this so it'll be there when you're ready for it. You're going to launch the Gizmo. Okay, once you've done that, you're going to go over here and you're going to open the Google Doc. When it loads. Okay, so you're going to have these prior knowledge questions and then a Gizmo warm-up questions just to get you used to what's going on with the Gizmo. And then you have activity A. It's still loading a little bit. And then you have activity B. Now there was an activity C, but I actually removed it because it wasn't really concerning this unit. So you've just got 2 activities to do today. And here's the Gizmo. Okay, so you've got periodic table, electron configuration, and atomic radius was that 3rd activity that I took off, so we're not going to be using it today. Okay, so let's just take a look at what's going on here. So it says Elvis Perkins, a rather shy fellow, is getting on the bus shown at the right. What seat do you think he'll probably sit in? So if you see here, you've got the bus driver and you've got 1 person in each seat except for this one, and it's empty. And so this guy, he's shy, but I would be willing to bet most people are like this. He's going to sit in that empty seat before he goes and sits next to somebody else, especially during COVID. So he's going to go sit down in this empty seat. And what's funny is electrons are like that too. They hate being around each other because they're negative, and like charges repel. Remember, they actually push away from each other. So remember, when we're filling those boxes, that you're going to have 1 electron in each box before you go back and double and make them sit next to each other. Okay. It says Marta Warren gets on the bus after Elvis. She is tired after a long day at work. Where do you think she will sit? Well, if she's tired, so Elvis is here. So now there's 1 person in every seat. And Marta is going to walk in, and she's tired after a long day of work. So I'm willing to bet she's going to sit in one of these front seats here. And so that's another property of electrons, is they will always fill up from the lowest energy level, which the front of the bus represents, and they go from low to high or further back on the bus. Okay, so if she had more energy, she could go back here, but electrons fill up their orbitals from lowest energy to highest energy. So she's probably going to sit up here representing that electrons fill up the lowest energy levels first. Okay, so in your experience, do strangers sitting on a bus like to sit with other people if there's an empty seat? No, they don't. And electrons don't like to be paired up unless there's no other choice. Okay, and that, again, that's kind of revisiting back to how we fill up those boxes with orbital notation. So looking at the Gizmo warm-up, it says, just like passengers on a bus, electrons orbit the nuclei of atoms in particular patterns. You're going to discover these patterns today with electron configuration. Okay, so to begin, it says check that lithium is selected on the periodic table tab. So let's go over here, periodic table, and we've clicked lithium. Now, if you want to change the element, you just change it. But we've clicked lithium, so it's popped up here. Okay, it says how many protons are in lithium. Well, if you remember, the protons are the atomic number, so the answer there is 3. Lithium has 3 because its atomic number is 3. Number 2, a neutral atom has the same number of electrons and protons, so how many electrons are in lithium? Well, if lithium has 3 protons, then it also has 3 electrons. Okay, it says select the electron configuration tab and check that energy is selected. Do that real fast. Do that. Energy is selected, so here's number, here's energy. Okay, so it says click twice in the 1s box at the lower left and once in the 2s box, and then observe the model at the right. So here we go. We're going to click twice here. That adds 2 electrons. And then we're going to click once here, and that adds the third. So here we have an atom. Here's the nucleus. It has 3 protons, 4 neutrons, and it has 3 electrons orbiting the nucleus. It says, what do you see? Well, you're just going to write down what you see. Okay. It says, then click check. Is this electron configuration correct? So where's check? We're going to click that. It says, yes, it is correct. Correct electron configuration. So this is the electron configuration for lithium. Here's the orbital notation, which you're used to doing, and here's the electron configuration. So as you can see, it's very similar, except instead of drawing the boxes with the arrows, we simply write how many electrons would be in each box. Okay? So there's the warm-up. There's the prior knowledge. I'm going to let you guys take it here for activity A and B. If you guys have any questions, feel free to email me, and then make sure just to submit this when you're done. All right, good luck, guys.